Hello, we are again creating a calculator in Scratch. So, this is the last video of this series, unless you guys can give some suggestions for things to make in the comments, and if I can make any of those, I will surely make a video. So, today we are going to be making HCF, which is highest common factor, LCM, which is lowest common multiple, and making a fraction, converting a fraction to its lowest form. So, though you might think these three things are completely random, maybe not HCF and LCM, if you think about it, reducing a fraction to its lowest form is just dividing the two numbers by their HCF. So, we can use the HCF code in that. So, basically, we are only doing two things. So, let's first do HCF. So, we can create a sprite and call it HCF. You can put highest common factor if you want, but I'll just write HCF. Now we are going to create our block. So the block will be, so you actually first, there is only two inputs because two numbers will be there. So it will be HCF of, you add an input which is 1, you add a label and another input 2. So very simple, run it through refresh. Now the crazy thing is that you would need actually 6 variables. They are x, also make sure to make all of them for the sprite only. X lowercase, y lowercase, we are going to create one that's called min, all capital will make it. Oh, sorry, there are not 6 variables, there are only 5. Now we're going to create one that's max. The reason we have these variables are one number will be more than the other, so these two we are going to set, and the last one is z for the sprite only. So these are the 5 variables that we are going to use. Later we'll hide all of them. So the first thing is we are going to get this set block, and we are going to set the x and the y. So we are going to set x to input 1 and y to 2. The next step, we are going to get an if else block. Now we are going to get this greater, less than, and put if x is less than y. So what we are right now just going to do is see which number is greater than the other. So, and we are going to set max to the greater number and minimum, which is min, to the lower number. So if x is less than y, then we will set max to y, and we will set min, which is minimum, to x. And we are just going to duplicate that, and in this one we are going to just swap these. So min to y and max to x. So we have done with finding which is greater. Now we are just going to set z to 1. Now we are going to use this operator mod. So mod is like you take a number line, and if you have like mod 2, then numbers lower than 2, which are 0 and 1, you can't go in negatives. You just put like 0 1 0 1 0 1 in the number line. So whichever number you are putting to some mod, that you just find which number it will get. So that's just what mod does. So now we're going to get a repeat until, which is over here. Now in the repeat until, we are going to do whatever we put in this block until z is greater than the minimum. So when this happens, we are going to get the HCF, which is what we need. So greater than, and we are going to get the min variable and put that over here. Now the code that we do is actually pretty long. So we get the if then block, and now this is what we are going to do. We get the mod, and now we get this input 1, and we are also going to use input 2. So if 1 mod, now we get the variable z, 1 mod z is equal to 0. So we get the is equal to and set this to 0 and put this over here and put that over here. That's not yet done because we have to also do this for input 2. So we get the and, we put that over here and we just can duplicate that. We can take this, we can duplicate that and just remove 1 and change it to 2. So now when we put these two, there's not enough space, I'll just put this here so we can put it. This is the code. If these two, if 1 mod z is equal to 0 and 2 mod z is equal to 0, then we can set, I forgot one variable, HCF. That's the 6th variable that I forgot about it. Then we can set this HCF variable, which we will speak in the answer. If these two conditions are met, then we will set HCF to variable z. So, but what if these are not equal to? So then we'll at the end just put a change the z variable by 1. So if this will eventually match the conditions and we will get the HCF. So once we get that, we'll just get a speak block so we can speak our answer. So we are going to get some joins. We need a ton. We need, I think, 5. Okay, that's 5. And the first we'll write the HCF of, now we get input 1 and 2. Something's happening. I'll just fix that. The HCF of input 1, we'll put and input 2 is equal to, and now we'll just get the HCF variable. So this is the code for HCF, and we are going to be using this for LCM with a few changes, and also for the converting the fraction to its lowest form. So we are going to test this now by getting our block, and we are going to be asking it the HCF of 60 and 80. It should give us an answer of 20. So let's see.
The HCF of 60 and 80 is equal to...
Oh my god. Okay.
The HCF of 60 and 80 is equal to 20.
There we go. It gave us an answer of 20, which is correct. So now we can hide all of these variables. Now this exact same thing, we are going to create another sprite. It should create. Okay, there we go. And we are going to be calling this sprite LCM. I need to delete sprite 1. I don't know why that's there. LCM. Now we'll go back to the code. Why are we in stage? Okay, I think it's fixed. Okay, yeah. So we are going to get the HCF code, and we are going to drag it and drop it here. So now we have this, but we don't want HCF, we want LCM. So right here we are going to change this to LCM off. So now we are going to be doing a few changes. So after this, z is equal to 1, we are also going to set the LCM we have to change this HCF, rename it to LCM because we are not calculating the HCF. You don't have to do it, but it just makes understanding better, and plus it also looks better. So set LCM to 0. Now over here, instead of z and min, we don't do that, and we are going to put a not block, and we are going to make it that the LCM variable is not equal to 0, because in our next code we are going to be using LCM. So LCM is equal to 0. So we will put 0 here. LCM is equal to 0. Now over here we'll just remove that code, and we are going to change it to we need to get multiplication, and we are going to put the minimum times the z. This we will calculate, and now we are still going to use mod with the same it's the same thing as before, but just with a little bit difference. So now we're going to get, we are not putting it there. Now we're going to get an equal to right here, and we're going to put it to the mod of max. Now we will put that entire thing over here. Now we will put that here, and we are not speaking anything right now. And if it's equal to 0, just like the previous one, but that time there were 2 conditions, now it's just 1. Then we set LCM to z, but we have to do one step, because we did min times z. We have to do the same thing over here. So we do min times z and put that over here, and this change z by 1 still applies. Now we are going to change this HCF to LCM, and this will give us our answer. So we can choose 2 numbers. We'll choose not the speak block, LCM of 4 and 5. It should give us an answer of 20.
The LCM of 4 and 5 is equal to 20.
There we go. That's LCM. And now we're going to create the final thing of this calculator, which will we will call simplify the fraction. I think that's a good name. Simplify the fraction. You can also put convert the fraction to the lowest form. Simplify means the same thing. Because I'll block also, I think I'll just put simplify. So we are going to write simplify this fraction, and we are going to put the number 1 for our input. But we can't like create a fraction by putting an underscore and getting 2 inputs, so we'll have to just create another, we'll put a label of a slash, which is like division, because a fraction is just basically division. So we will use this, but we will do that code later, because our HCF code we are going to be using in this. Like I explained earlier, basically simplification of a fraction is just dividing the numerator and denominator by the HCF of them. So over here what we are going to do is we are going to create 2 new variables. They are also going to be for the sprite only. Capital X, because we already have lowercase x, and capital Y. These 2 we are going to use. So we'll now go to simplify this fraction, and we will set x and y to inputs 1 and 2. Now over here, all this 1, 2, all that stuff, we are going to change it. So now we're going to remove this, we're going to remove this, and we are going to we are not calculating right now anything. We're going to click edit, and we're going to remove these inputs, remove them, and this will just be called calculate HCF. That's it. That's all it will be, and we are going to just be using this block. And we are going to put this calculate HCF in that. So how we have set this input 1 and 2 to x and y. So we are just going to use x and y here. So we set the HCF in the HCF calculate HCF block. We'll just set lowercase x to the x which will be in this block, and y to that. And over here we will do the same thing. X mod z. That code went down there. Can I get it? Yeah, got it. X mod z. It again went down. Oh my god, this code doesn't want to stay properly. X mod z Yeah, now it's fine. X mod Z, and okay, I think I'll just do it like this. I don't want it to again go down. So this code will calculate it, but we don't want the speak block. That's it. We'll just remove it. So we will calculate the HCF. So we set X to 1, input 1, and Y to input 2. Now we are going to get the calculate HCF block and put it here. So now it will calculate the HCF. And now we set X, make sure you choose the capital one, 2, and now we are going to get X and Y again, but we are going to divide them both by the HCF variable. So X divided by the HCF variable, which is what simplification of a fraction is. We just divide both them, both the numerator and denominator, by the HCF of them. So after we do this, we'll get our speak block and write the simplification of the fraction. And oops, I forgot to put this in a join. We will need, I believe we'll just put joins when we need them. Let's just start off with 3 because I don't remember how many joins we need for this. So nope, we are not speaking right now. The simplification of the fraction, and you can put input 1 over 2, input 2, or input 1 by 2, because most people use over. I'll just do that. So input 1 over, we are going to need a join here now, over 2, we again need a join, is equal to, and now we are going to be putting another join, and another join, and over here again, because we put over before, I'll just put it again. Now we are going to write our variable X and Y, because we reduce them by dividing them by the HCF. We can just put them over here, and that will be our new fraction. So this should calculate the simplification of the fraction. So we'll get that block. We can't hide this because we are using it, so we'll just have to stay with it. Simplify this fraction. You can change it to the fraction if you want. We are going to simplify the fraction 100 over, also it can't calculate something like 100 over 10 because you can't divide it then. So we are just going, I'm not sure, we can just test it. 100 over 10, it might be able to. Let's see.
The simplification of the fraction 100 over 10 is equal to 10 over 1.
Okay. It doesn't fully simplify because you don't say 10 over 1, you just say 10. But I feel like that's good enough. So now let's check the other one, which will be something like 5 over 10. It should give us 1 over 2. Like 1/2.
The simplification of the fraction 5 over 10 is equal to 1 over 2.
There we go. It has simplified the fraction. So this is the last video of creating a calculator. We have created HCF, LCM, and simplify the fraction. Put some ideas in the comments. I have also made a community post. You can put some ideas there, and I will surely create more videos with the ideas. So thanks for watching.